Okay, to know from now on, that means your lecture day will be on Friday, online. Okay, you are in the tech two. That means almost will be complete the program. If you want to get a completion certificate, then you have to do the job. Okay. First thing is we go up to the digital lab number 8. Okay. Today, I will be talking about the digital lab number 7. I know for sure, few students still cannot get up until 7. Maybe you get 3 or 4 or 5 or 6. However, if you understand the 7, the way we're doing the lab, that will be no problem when you're working on 3 or 4 or 5 or 6. Okay? Okay, you get any question to me?
No.
Okay? If it's not, then you can see the lab 7 or 6 or 5 or 4 or 3 the same way. Okay? If you understand 7, then you can get the other one done quickly. Okay? So, first thing, I want to talking about the process to complete the digital lab. Okay, so that is basically the process how you're able to complete the digital lab. First thing, you have to get the complete the Excel file. Until the status pass. If you cannot get it done, you have to add the instructor, or if I'm in the class, you can ask me, I can help you out. Okay? That is the first thing you must be getting past. The second step, after you get it past, and now you have to complete the test program to test the circuitry. In order to do it, you know how to using the Visual C++ to create a new project. And you can using the data in port A or B or C or D, or P clock function or N clock function to code it. Okay? That's the only thing you need, the data for you, how to coding your program. And number three, you can build the circuit. And last one, you can test the circuitry. If it passed, that means you're done. Okay? So that is very, very basically, you have to follow that instructions in order to get your digital lab done. So, first thing, you get any question, anything related into this process. No? Okay, now I'm talking about the DLAB07. The thing is DLAB7, the same thing, the lab 6 or 5 or 4 or 3. That means you don't have to understand. The thing is they just using the simulation. Okay? The simulation program will be asking for the input circuitry, and they will be given you the output. Okay? So, first thing you're looking on the DLAB7 here, how many IC in this circuit?
Two.
How many? Okay, now you have to pay attention. I'm asking you, you have to answer to me. I don't want anyone just log in to the Zoom and try to do something else.
It's two.
How many IC? You said two?
Yeah.
Who else?
Me one, you two.
Okay, you also get two. One more. The thing is, you have to talk, okay? I know if you not quite understand, that's why I'm able to explain to you. Okay. How many IC? That means how many units in the circuitry. In order,
Oh, it's 4.
you say 4. That's okay. Now I will be talk to you. Okay. In order to know, you just count on yield. That means unit. They can be U1, U2, U3, U4, U5. That doesn't matter. 1A or 1B or 1C. That not mean you get another IC. U1 is 1. U2 is 2. And U3 will be 3. So this circuitry will get 3 units. The first one will be 74, 76, U1, U2. And the last one will be U3, 74, 08. So you get 3 IC. That means 3 units. Okay, anything else? If you're still confusing, bring it up. Okay, so you get 3 ICs. 274, 76 JK flip-flop. And one will be AND gate 74, 08. Okay, and the next question. For this circuitry, how many inputs to the circuitry?
Two.
How many inputs?
2.
Okay, who else? The input, that means you're able to connect from the control box to your circuit. That means you can get port A, port B, port C, or port D. And also you can get another 2 clock signal. P clock positive going transition, or N clock negative going. So if I'm looking on the circuitry, I know 14 PA here. 1 input, PA here. Second one. And also you will be need the N clock. So that will be telling you this circuitry get 3 inputs. Okay. And how many outputs?
Four.
How many? Just let me know how many outputs.
It's 4.
Okay. Now, you can see normally they're using the port A or B or D for the inputs and the port C that for the output. So you can count here 1, 2, 3, 4 for output. That means you can see when you already build, you connect to PC pin 1, pin 2, pin 3, pin 4. That is for output. Okay? So the circuitry get 3 inputs and 4 output. Now, the thing we're using the simulation program, then you have to give to the computer what the input that will be given to you right here. This is the input and clock. The next one will be PA01 for preset and PA02 for clear. Okay, now again, I want to talk to you quickly here. That is a preset. That will be a clear. Okay, and that will be Q. Preset is 0. Q must be 1. That's what we already get through it. Okay? And if clear 0, then Q must be 0. Even they get a clock in here. That doesn't matter. That means sometimes they want to set the Q to be 1. That means they set preset to be 0. If they want to set the Q at a 0, doesn't matter for the clock signal, then clear 0. Okay? However, you understand that both preset and clear cannot be 0 at the same time. Okay? So if you get preset 0, then Q must be 1. Okay? Then Q will be at logic 1. And if they want clear, to clear the Q to be 0, then you have to do same way. That means if the clear 0, then K preset must be 1. And the output now will be 0. That means preset and clear cannot be zero at the same time. Okay? In the circuitry, everything be controlled by the clock. They can be positive clock or negative clock. Okay? Then they will be telling you for the clock operation. If you apply the clock, this will be high to low. 1 to 0. And if you want to know the output Q, that depends on the truth table. However, preset must be 1 and clear must be 1. So the clock can be working. Okay? Now, in here, they already telling you the clock will be 0 at the beginning. Okay? Then they go 1 and 0 to 1, 0 to 1, keep repeated. And also you can see at the beginning, preset to be 0 right here. Okay? And also clear will be high and later they go low. This input will be helping you to tell the computer to give you the output. Okay? You know, this will be inside include here. Okay? That means you're using the include file. You add it for this signal. Okay? And now I can see the first one, they want to test what? They want to test for the preset. Then preset will be 0. And look, if you're looking into the timing, there will be 1. So what the output supposed to be?
It's 1. F, right? 1, 1, 1, 1.
Perfect. Preset 0, Q must be 1. That's what you will be collect when you run the simulation. And the next step, they want that for the clear. If you're looking into here, you can see clear 0 and preset have to be 1. Okay? What Q?
0.
Perfect. 0. So that's why you can see, okay, at the preset or clear, you don't care about the clock. Okay, now they want to test for the clock number 1. In order to collect the output, I'm telling you, this is preset, this will be clear, and the clock, this clock will be negative going. So you collect from high to low right here. So in the simulation, what you get, you can put in here. Okay? And the next clock will be here. Not this guy. Have to be on that one. Negative going. And the next one will be on that one. And keep do it. And you can get the data you put in the queue output here, okay? What they supposed to be, okay? 1 or 0 or whatever. That means you complete the truth table. After you complete that one, okay? If they tell you, and you can go to the next one. Okay, now quickly I'm talking about this IC. That's what you're using. 74, 76, JK flip-flop. How many flip-flop inside one IC?
2.
How many? How many flip-flop inside 174, 76 IC?
2.
So, perfect. This is a 1. This is a 2. 2 flip-flop. Okay. And this will be how many pieces on this IC?
16.
16. Okay. You can say 1, 2, 3, 4, 5, 6, 8, 9, and 16. Okay. The next one. Normally, you have to connect the power and the route for each IC. For this 74, 76, when you connect to power 5 volt, what pin?
5.
Perfect, right here. They show you right here. If you connect it wrong, they can cook the IC. Okay? What pin for route on this IC?
13.
Perfect, right here. 30. Okay? And now, I get a question, what pin number 1 doing? What pin number 1 doing?
It's the clock, right?
Right. This is the clock. You can go this way. Here. Clock of the first flip-flop. And this is the pin number 6. Is the clock for the second flip-flop. You can see they say clock 1 and clock 2 for this second one. And also which pin will be preset or which pin will be clear. Okay. And what pin will be output Q1. This is not Q1. Or what pin for K or J. Okay. So you're looking into the schematic, you're able to identify. That's what your job when you're working in the company. Okay. You see that IC, you don't know. You can go to the Google. You can type in 74, 76. They will give to you on the information. Okay. Now, you have to quickly answer this. Okay. For example, they're asking how many JK flip-flop inside the 74, 76 IC. And you know the answer will be 2, right? Which pin is the power of this IC? And you know pin number 5. And what pin will be the route? You know pin number 13. For the fourth flip-flop, which pin is the clock signal? Okay. I say pin number 1. And so on. You have to get this complete. If you get any question, anything, okay, just let me know. The thing is, you don't have to say you're working on number 3, they done. You don't have to working right away. Left number 4, left number 5, left number 6, okay? You can working on left number 7. And after 7, you can go back to working on 4 or 5 or 6. Okay, any question to answer on this quiz here? Okay, if it's not, now we're talking about data for port A, port B, port C, port D, port E. Okay, and clock. So the first thing you said, that preset, the clear and the preset, you know that have to be 0, that have to be 1. Okay, easy to do. You can go into that one here. You copy from that one. Okay, copy from here. Then you can paste them out. To that one. Are that clear? And I know that will be 0. And that have to be 1. The next one, number 3, that clock signal. Then both have to be 1 and 1. Okay? When you try to enter a data here, you cannot enter. That I just telling you. For the port A, you can take one, you writing that. That will be 08. Zero 02. And that will be 08. 01. That will be 08. 03. And that 4, 5, 6, 7 up to 13. They don't want to, you don't have to apply data to port A. So that's why I'm not allowed you to write it down. Anything else here? Okay. So that is a complete the data for the part A. If you get any question, just let me know. You understand the one we not using pin 3, 4, 5, 6, 7, 8 normally do not using, they will be automatically will be 0. But you don't have to put it in. I want the data 0x02, 0x01, or 0x03. Any question to complete the part A? No? Okay, if it's not, we go to part C. Part C for the output. However, what they're telling you, for each block test, you must apply positive going. No, that will be negative going. Something is wrong right here. Negative. The thing is you're using and clock. Okay? That means negative going clock signal. So on the preset, and you know, okay, you have to be 1, 1, 1, 1. For the next one, clear, you know Q will be 0. Okay? Now, the data for that one will be 0x, 0x, right? And that will be 0x, 0, 0. Another thing, how many pins on port C? This is the port C here. How many pins?
It's 8.
How many?
8.
8 pins. You see that? PC 1, 2, 3, 4, 5, 6, 7, 8. When you're using the control box, you can see on port C they get the 8 pins. Okay? However, on this circuitry, you're not using on the 8 pins. How many pins you using? You're using PC 1, 2, 3, 4, only 4. Okay? So you have to tell the compiler, I'm using only 4 pins. And pin 5, 6, 7, 8, I don't care. That's what they're talking about, math function. Math function means you tell the compiler which pin you want and which pin you don't care. If you don't care, that means they will be 0 here. 0, 0, 0, 0. And the pin you're using, you want it, they will be 1, 1, 1, 1. Okay? The thing is when the computer reading, they reading 8 pins. Okay? They're not reading only 4, they're reading 8. And now you tell the compiler, I don't care. Pin 5, pin 6, pin 7, pin number 8. You enter 0. That means what? Well, after they reading 8 pin, they take pin 5, pin 6, pin 7, pin 8. They end it with 0. So they read 1 or 0 and with 0, they still be 0. Okay? That's what you don't care. And the care will be the pin you're using. 1, 2, 3, 4. So the mask data here, they will be 0x, 0, F. That's the mask data. And the P-corp, that means if the test failed, what caused the problem? We're not talking about that. After you guys get through the process, you do the lab, then now we can talking about when the test failed, which IC got the problem. Okay? And now, in order to get the data for port C, same thing. You go into that one. After you done data here, you copy that data and paste it into port C. You see that? You can paste it in here and try to scan it into the hack data 0x, 0, 1, or 2, or 3, whatever. That will be helping you to get it done for port C. Anything, any question regarding into complete the port C. After you understand that one left for port A or port B, port C, port D, or N clock, P clock, and later on will be easy for you. Okay? Any question?
No.
You have to bring it up. Okay? Right now, you understand it on take 1. I talk to them, I teach them, same thing like we're doing in the class. They working, they do it, they let me know. Or any question, they bring it up so we can help. I don't want to talk to, nobody can try answer any question. You have to tell me how much you understand. Okay, so you get any question regarding into complete the port C in this lab? No? Okay. Now, after you get the status here, if they pass, then you start coding your program. Okay. If they still fail, don't do it. Don't code in the program. You need to talk to the lab instructor or myself in order to helping you to understand, to make it pass. Okay? And now, the other thing I want to bring it up to you. We already given to you the lecture on the counter. Basically very simple. Counter, they can be just a counting the number. They can counting 0, 1, 2, 3, 4, 5, 6, up to any number. That means they counting up. And also they can be counting down. That means they can counting from 15 to 0. So 15 then go to down 14, 13, 12, 11, 11, 10, 9 to 0. That means they can get up or they can get down. They count up or they can count down. Okay. And now they can get the number 1, B, C, D counter. Okay, BCD counter. What stands for BCD? BCD means binary code. Decimal. What that means? That means they are binary, however, they working like decimal. So BCD, if they count up, they can be 0 to 9. You cannot get 10, 11, or 12. The thing is, decimal will be going from 0 to 9. Okay? Or they can be count down if they get 9 to 0. 0 to 9, then to 0. 9 to 0, then to 9. Okay? They keep counting if they still get a clock. Okay? Keep going that way. And the next one, on lab number 8, binary. Counter. Okay? Binary counter, they can counting 0, 1, 2, 3, up to 15. Count up. Zero to 15, then back to 0. The thing is binary 4 bit, you can go up to 15. And counting down. Will be 15 to 0 and to 50. Okay? So basically now you understand for BCD counter and the binary counter. Okay? they just count number. They count up or they counting down. However, BCD, they count up, only go up to number 9. The thing is decimal don't have a number 10. Okay? If they count down, they can count down from 9 back to 0. However, binary counter, okay, they can count up from 0 to 15. 15. That will be 4 bits. Okay? It's the same thing by BCD counter 4 bits. However, the difference will be one going from 0 to 15 and to 0 if you keep counting. Or down from 15 down to 0 and they go back to 15. Okay? So any question, anything?
No.
Okay, the thing is, when you done for your lab, you build it, you run it part. It's not completely what I want. Okay? I will be asking you to make sure you understanding what's going on. And also, the main thing I want to take to you, after you done for your software, your program, you done for building the circuitry, when you run, they fail, then what can we do to solving the problem, to fix the problem? That's what I want to teach. That's what we're talking about, troubleshooting. I don't want anyone, when you run it fail and you try to check the wiring. No, don't do it. We have to using the DMM. That's what you're supposed to be doing at your work when you get a technician job. The thing is, you understand in the company, the circuit board on the wiring will be in the middle of the layer. Okay? Then we don't care about they be broken. No. Only thing is the part is not working. So that's why it failed. So that's asking for you to troubleshooting. You find out which part not working. That's a main thing you want to do. Okay? So up to this point, you get any question, anything else? Okay? So the next meeting, I will be talking about DLAB number 8. The thing is, the lecture in the textbook is not much. Okay? So that's why involved much of the thing will be a digital lab. You will be learn about memory. Okay? And learning about A to D converter, analog to digital converter, or DA converter. Okay? But the lecture will be short, if not too much. Too many things. Only thing we're doing a lab, you're working with that device. If you understand, that means you're able to get through the job. Okay? That, to me, that's good enough for today. You get any question, anything else I can help? You have to get all of the digits on left to be done. Then we can talk. Okay, anything? Okay, so if it's not, then I will be stop it. Okay, so will be good night to everyone.
Good night, Mr. Pham.
Good night and have a good holiday. Okay,
Yeah, you too.
bye bye.